Awesome. All right. Good morning, good afternoon, good evening. Welcome from wherever you're joining us. Today's webinar is on common anti-patterns and refactorings. Now, a heads up that we are going to be live streaming this on YouTube currently, and then the recording of the webinar will be available in the webinars playlist right after. So heads up that this is getting recorded and stored on the YouTube side of things. If you want the thank you email with the supporting links, the YouTube stream does have a link that you can sign up to get that video or the email. So rest assured, those emails have not gone away. All right. So when it comes to common anti-patterns and refactorings, I couldn't resist creating a slide like this. It's just so much fun. Because, yeah, how many of you are working with legacy code and the pains that come with that?
Oh,
Yeah.
yes. Couple of 20-year-old applications, actually.
Oof. Yeah. So not the pains of one app, but multiple older apps. So yeah, you're going to see a lot of anti-patterns and a lot of refactoring things. Some things that I'm going to point out. So when we talk about anti-pattern, when I say anti-pattern, the word art does have some of these refactorings in there as well. So don't get too hung up on those, but just know that an anti-pattern is a recurring solution that we see in our software that produces problems. So they seem effective at first. They seem like, hey, this is pretty awesome. However, at the same time, it's going to lead to more problems in the long run. Now, there are going to be some things where I talk about the trade-offs, because there are some trade-offs. And some of these anti-patterns aren't always an anti-pattern. So we'll talk about those in context as well. But the question is, why do these anti-patterns happen? So the first reason, and this one is more common than I think any of us realize, is that lack of knowledge or experience. I can tell you prior to Nimble Pros, one of the positions I was in, I was responsible for creating admin portals and another admin portal and another admin portal. And I ended up leaving that because I felt like I was stuck doing the same thing over and over and not growing my knowledge. I wasn't getting into the distributed applications that they had. They just wanted to keep me on admin portals. So I was out of there. That lack of knowledge and lack of experience is crucial to understanding why some of this code is as bad as it is. Uh, to be fair, I look at my legacy code and go, well, I didn't know about this then, so let's fix it now. So lack of knowledge or experience is the first one that I have to stress. Now the next one, this one hurts. That's time pressure. Because how many of you are in a position where you've had that project manager go, by the way, we need that feature, and we promised the feature to the business yesterday, so could you just get that done? Can you deal with it? Or oh no, there's a fire in production, now we have to go and do a hot fix. That whole, you're under pressure, tight deadlines, you gotta get things in, quick fixes, and sometimes those quick fixes are also not what you wanted to do when you actually had time to focus. So now you're putting anti-patterns in your code, but you got to rush it because you got to get it done because those tight constraints. That's why I do the this is fine. We've seen that a lot. Misunderstanding requirements as well. This is another one where you go into a project or you get a legacy application and you see things are looking pretty funky. Know that the requirements might have been misunderstood. You could have had somebody say, oh, we want this application to do XYZ. You write the code and they're like, honestly, it should be doing ABC instead. Well, the pattern you chose to solve XYZ worked well for XYZ, but is an anti-pattern for solving for ABC. So misunderstanding means you also are making choices based on the knowledge you have. And if there's a misunderstanding and a miscommunication, it's easy to choose a wrong pattern because you're only working with what knowledge you do have and what understanding you have. All right. So lack of knowledge, time pressure, misunderstanding requirements, legacy code. So Steve mentioned two 20-year-old code bases. Legacy code in general does have a lot of anti-patterns in it. And I was thinking about this when I was working on this presentation. If you go back to those legacy code applications and think back to, okay, who created this? When did they create this? Did they create this when they were early in their career? Are they a lifer? Are they one of those people who has been at the company for decades? So their only experience is within that company, which means they may not have experience to better coding practices. And so now you have anti-patterns in there because that's all they know. Legacy code, we have to be a little bit more gentle about it because it got you to where you are today. It still works enough, but it's one of those that the anti-patterns there are probably that whole lack of experience or even a lack of knowledge. Technology constraints is another issue that we see where anti-patterns arise. What happens there is you see people who, again, goes back to lack of knowledge or experience too. So if you don't understand the technology that you're working with wholly, so if you don't understand, for example, Blazor and Signal R, you might not be able to take the right advantages of that because of those gaps. And you might be doing some anti-patterns there, such as storing too much stuff in a pre-rendered state and then things going kaboot. Anti-patterns like that happen when you don't understand the technology that you're working with. Also could be with dealing with scaling applications, both with horizontal scaling and vertical scaling. And yes, we can deal with that virtually now with containerization, but could you imagine dealing with that with actual hardware? We still have hardware as well. But again, there's that anti-patterns. The why do we do things this way? It's because this is what we know in this time. The last excuse I have for anti-patterns is the cultural or organizational factors. Part of it is that there are some companies, and I've worked with some in the past, where the culture is, but like the company culture internally is okay, but then you get into, well, why do we have all these hot fixes all the time? Every release is a hot fix. What didn't get tested? Oh, that's because we don't have tests. Or, oh, our QA is spread thin. And so they only did a high level look at things. These are tough. Some other organizational issues we see are like a lack of code reviews, or you have people who are doing code reviews who have the same level of experience or the same level of knowledge. And so there are gaps that neither side has. It's tough. The quick and dirty mentality. Gotta get the apps done and get them out right now. All of these can lead to lots of releases of anti-patterns. So that said, how do you avoid them? Well, learn and follow best practices. Now, you're here listening to this webinar or watching this webinar, so you know that you need to see what else is out there. You've seen bad code, you may know some ideas for refactoring, but you might not know other ones. So hopefully everybody will learn something new today. But at the end, I also have recommendations for books. So rest assured that, how do you think I learned some of this? A lot of it's trial by fire, working in the field. But there are also books out there that are really good guides. How else can you avoid anti-patterns? Well, when you look at your code, actually look at the code and think about the code. And so look at, how do you write it so it's clean and well structured? And that's clean with a lowercase c, as in like, is this actually code you want to work in? Is it readable and is it maintainable? There are other ilities that could apply to that, but these are the two that I would stress for avoiding anti-patterns, because a lot of anti-patterns, like the quick and dirty, you look at the code that I'll show you and you're going to be like, well, yeah, that code looks okay. But then when you see the refactoring, you're like, oh, yeah, there's better readability there. Or, oh, this makes sense. How else can we avoid anti-patterns? Well, do code reviews. And code reviews should be with somebody typically more experienced than you, who can look at your code and make sure, does it do what you want it to do? Okay. Does it involve good practices for the situation that you're in? Even better. No, I need to go back to that first bullet point where we talk about best practices. I don't like the term best practices because of how generic it can be. Everybody's like, oh, here's best practices on code, and it applies across the board. And I'm here to tell you no. You need to consider the situation. You need to consider the instance that you're working in and the problem you're trying to solve. And does it make sense for that? So conduct code reviews and see if the code that's coming in actually makes sense for the situation that you're dealing with. How else can we avoid anti-patterns? Well, write automated tests. Lack of tests definitely allows these things to go into production easily. That said, when you're writing tests, make sure you're writing tests that are actually testing value and not just testing for the sake of testing. And the tests that I call out are unit tests and characterization tests. And the reason why I call out both of these is unit tests are something that you got a greenfield application, you're starting from scratch, you can incorporate unit tests very easily. But like Steve with his 20-year code bases, 20 years ago, testing wasn't that big of a conversation. It was maybe thought of, but it wasn't as prevalent as it is today. So you might not have tests in a code base that old or that large. Characterization tests allow you to test how you expect your app to be. And so you're working with what you have. Then the last step for avoiding anti-patterns is to refactor regularly. That said, as you're looking at your code and you're like, I don't think I can refactor this further, then that's fine, let it be. Don't get hooked up on the term regularly too often and looking at all of your code like, oh, do we have to refactor it all the time? No. Refactor the pain points when you see them. Okay, so we talked about the sources of anti-patterns and how to avoid them. Now let's go and look at what the anti-patterns are and refactoring to them. Because if we refactor them, they become a little more readable, more maintainable. Let's make sure we're clear on what it means to refactor. So when I say refactoring, I use the term refactoring as a noun, but then the verb refactor as well. So basically think of it as you've got your code and now you need to improve the design and structure of that code. You need to make it more maintainable, more readable, maybe more scalable, maybe more secure. So software architects, you're thinking of all the abilities, the quality characteristics, the requirements, those kinds of things. But you want to improve your code somehow. Refactoring is what you do when you start rearranging the code and rebuilding it. Now, each refactoring that I'm going to talk about today should be seen as a tool and not as a golden hammer like Thomas in this picture shows. You want to use each of these refactorings when they are appropriate. So don't be like, oh, I see this factory pattern. I need to use the factories everywhere. No, 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 no. Or, hey, that looks like mediator. We can use mediator everywhere. Just because you can doesn't mean you should. There are going to be some anti-patterns that I call out that you'll be like, that's really an anti-pattern, but when you see it, you'll have that moment of, oh, this is why you're calling it an anti-pattern. So rest assured, some of these things are going to be like, well, and then when you realize what the refactoring does, you'll realize it's an anti-pattern sometimes, not all the time. Now, for those of you not familiar with these webinars, I usually do this around lunchtime where I'm located. So there's usually some kind of food reference. The other thing is with it being fall, I was like, well, I could do something scary all the way through. Or I can also make nods to pumpkin spice and apple of flavors of the season. So we're going to go with the bakery story. So expect references to cakes and donuts. There's another one, breads. So. Now, the code that I'm about to show you is not going to be as scary as you think because I'm not showing actual legacy code. And I do have some comments in there to highlight a bunch of things. So don't panic if you're like, oh God, what are we going to get ourselves into? Some things are simplified intentionally, starting out here with the God object. All right, so the God object is, think of it as that single class that has all the responsibilities. Everything gets put in it. I like to think of it as the class where it's like the junk drawer and then some, everything goes in on it. So in our example here, we've got the bakery class. And at the bakery, it's going to bake the bread, it's going to decorate the cake, it's going to make the donut, it's going to sell the items. But we need to think about our code. Sometimes we need to think about our code and personalize it a little bit. And so with a bakery, think about it. Is the person who's baking the bread also the person who's decorating the cake, also the person making the donuts, also the person selling items? Maybe in a mom and pop bakery shop, maybe in a small bakery shop. But typically you have bakers, you have cake decorators. Your bakers may bake donuts, but let's keep the bread and the donuts separated because they take different things, different steps. Are we talking about cake donuts or raised donuts? Those are different as well. And then selling items is usually a cashier or a salesperson. So why is the God class? Why is bakery doing all these things? That's why this is an anti-pattern, is it's doing way too much. So how do we solve this? For this one, I want to bring in the single responsibility principle. Now, the single responsibility principle is making sure that it's doing the one thing it's supposed to be doing. Now, with the exception of baker, our baker happens to both bake the bread and make the donuts. So that's why those two are with baker. But our decorator is good at piping those roses and making the basket weave on the cakes. But when it comes to actually making the dough, not so much. So that's our decorator. When it comes to selling items, that's our cashier. So sometimes you have to think of the code as if you were a person who had all these responsibilities, is that a good position to be in? Now, I know those of us who've worked in a startup have worn all those hats, but honestly, our code in that kind of state would be atrocious to maintain. And so God classes we want to get away from, and God objects we want to get away from. Now, the next one is what I like to call the switch statement nightmare. And this current state looks pretty tame. So, I mean, you see here, we've got the switch and okay, bake bread, bake cake, bake donuts. But those are just comments. What I have seen in the past, especially with inexperienced developers, is that they will put that logic right here in that case statement. So all the steps needed to bake bread would be in the case. All the steps needed to make cake would be in that case, and so on. So now this is getting really long. Then, okay, now let's say that we want to add pumpkin roll. Let's say we want to add macarons. Let's say we want to add something else in there. What if we want to make a cronut, so a croissant donut? What does that look like? Okay, now this switch statement is going to get more and more complex. And then longer and longer and longer, which will lead to another anti-pattern here in a little bit. You'll see this switch statement again, but just know that putting all that logic in the switch statement is going to be really gross and really hard to maintain because eventually you'll have all the code. Yes, you can rely on the indentation of the code, but at the same time, do you really want to have to scroll and scroll and scroll to see all your cases? Now, granted, some modern tooling will allow us to collapse our cases and all, but some isn't there yet. So we'll talk about how we can use polymorphism and factories to go around. So let's go back to our switch statement and point out one other thing. So I have this bakery class, this bake item function, and I'm passing in a string of an item. Now, do we really want to do all of this action in the switch? No, we want to be able to pull the action out somewhere else and then call it. One of the approaches is we're going to take a polymorphic approach. So we have a class called baked good that everything will inherit from. And our baked goods, they all can be baked. So we have bread, we have cake, we have donut. Now what's nice is that you can put the steps for baking bread here in its own bake method. Even better, but not seen on this slide, is that this could be bread.cs, this could be cake.cs and donut.cs. So not only are they separated by their objects, but they're also in separate files, which again makes it easier to maintain because you're not like, okay, I gotta sort through where's bread. Okay, now let's go through and change the lines here. Meanwhile, your switch statement is growing. So separating it out and taking a polymorphic approach is a possibility. And once we have the polymorphism set up, then we go into the factory pattern. And so with the factory pattern, we're going to have a create method, which is here. And then we're going to say, okay, based on whatever string I pass in, give me an object. So then if I want to create a new macaron, for example, I would say, okay, put macaron equals new macaron, create a macaron class that's going to inherit from the baked good class, and then override bake for the macarons. But then with create, it just goes, okay, let's go ahead and create a new whatever you need to create. So the logic is separated out. It's a little cleaner to read, a little cleaner to manage as well. It's another layer, but it might make sense for the problem that we're working with. So once you've created the abstract class plus the concrete classes plus the factory, now you actually have to use the factory. And so in the bake item, again, we're still passing in that string, but we're going to the factory like, hey, factory, can you create me this item? And it's going to go ahead and bake it. Otherwise, it's not found. So pulling out that logic will make that switch statement much more concise and easier to read. And like I said, that switch statement will come back here later. Another anti-pattern we see is the mysterious name pattern. Mysterious names appear in various forms, so I'm going to show two of them here today. The first one is when it comes to functions. So if you've ever seen, I think it's one of the pages on our deviq.com website, I talk about a void and do stuff. Never use those demos as actual production code. When you go and see a class bakery and void do magic, what's magic? What in the world is going on? Yes, the comment says bake a cake, but do magic? When I see stuff like this, I usually have to ask the developer, why do you hate your future self? Because future you is going to look at this code and wonder, why am I calling do magic here? What's really going on? If you have to look at your code and say, what's really going on? You need to refactor it so you don't have to keep wondering every single time you pull up that code. And trust me, I've been there. That's why I say every time you pull up certain pieces of code and you're like, why? What did I do here? You need to clean it up. So the anti-pattern of the mysterious name is, it's named something, but I don't know what this actually represents. But we'll take a look at here what it means to do renaming. Now, this particular demo here, it was recorded in Visual Studio Code using the C# dev tools. So I'm going to right click on that do magic, tell it rename symbol. And we'll make it called bake cake. And then notice that it changed my name for me. So now in my code, I can actually call bake cake, which looks nice. But the thing to point out here is that you have your tools. We didn't always have this kind of tooling in our IDEs or in our text editors. Modern tooling is a blessing because we have these tools to help us. Take advantage of them. So again, Visual Studio Code with the C# tools works great when you have to deal with something like this, because then it adds the support for suggesting refactoring things. There's some basic stuff inside Visual Studio Code to start, but get the C# extension if you're using Visual Studio Code for C#. Now that's bake cake. But let's say we want to bake a cake of a particular size. Okay, well, as developers, sometimes we're like, well, size is an integer, so int and x. Why x? It's one of our defaults. X, Y, I, J. But again, what is x? When you look at this whole method signature, you've got the method name, you've got the return type, and then you got these parameters, but there's nothing here. Now, don't be that person who then adds the / comments and then says x is the size of the cake. If you see that the variable name is like, it doesn't make sense, rename it. Don't rely on the documentation to say, oh yeah, by the way, x represents this. We are also long past the days of mainframe computing where field names were just only a few characters long. Make sure to be descriptive in your variable names as well. All right, so with this, Instead of X, let's actually say that we're baking a cake of a particular size. So we can rename our variable. And this demo is using Visual Studio 2022. As with all my Visual Studio demos, I use Visual Studio Community Edition, so that way everyone following along can do this. And this is just baked into there. So I'm going to right click on the variable to rename, include the comment. And the reason why I say include the comments is because this particular example actually had the variable name in the comments. So again, knowing what your IDE can help you with in refactoring can make refactoring a little bit easier. Now, this particular demo, I was only working in one file, but if I had references to these in other files, it would also update that as well. So certain variables or method names or function names that get carried into other files, your IDEs can refactor those for you. All right, the next anti-pattern. This one is long functions. So this is our switch statement again. Now, remember I mentioned that these are just comments, but these could be very long. This could be the switch nightmare. This could also be going on and on with the different functions for the different things. So we're like, we've got bread, we've got cake, we've got donuts, we've got cronuts, we've got croissants, we have cookies, we have brownies, we have coffee and tea and juices. So now the bakery's items and things that can't be baked and things that can't be baked, it all gets to be long and weird. But the code, it's long. That should worry you. And when I say worry, wonder why you have so many lines of code within that particular function. Functions can usually be boiled down to a few lines of code, maybe up to 10, 20, double digits fine. Once you start getting into triple digits, you really got to look at your lines of code in that function and go, what's going on here and how do we make it so it's more smaller and manageable? Another telling tale is if you see regions in the code. There is a place for regions, but more often than not, people are using regions to hide code. Modern IDEs, Visual Studio, JetBrains Writer, they allow you to collapse the code using the things on the left-hand side. So the arrows, you can collapse those just fine. There shouldn't be regions in your code. If there's regions, again, you probably have a long function, or you may have a God object or a God class, or you may just have a long class. Question regions. Consider extracting your functions. Now, this demo is also Visual Studio 2022, and we'll go ahead and play it so you can see. Of course, demo code, I'm just doing console write lines, but imagine if this were logic. So I do an edit and a refactor, and then there's the option to extract function. Give my function a name. Notice it changes the name there, and then it puts the function down there. Extracting functions, extracting methods. It's a beautiful thing when you let your IDE help you. Now, when it does it, it says static void. If you want to make it private, make it private. If you need a public, make it public. But this gets you down the path, at least a step. Now, in this other example, you can see that we talk about, okay, here's our switch statement, but then there's baked bread, baked cake, baked donut. So refactoring those out to methods. And again, we had other options, other refactoring suggested earlier for the switch. So again, keep in mind with these refactoring suggestions that not one suggestion is going to work for all solutions, but these are all tools in your toolbox. So each of these refactorings are something that you can use. Another thing that you can consider is replacing a function with a command. Now, what this looks like, so these are commands that you're seeing here. Commands come with the execute method. So when you go to use it, you're going to say, hey, I've got this command, execute it. The command is written, and it's one of those where it's pointing and written in present tense in a command form. So do this thing. So bake donut, bake cake, bake bread. It's usually a verb and a noun. The commands themselves, when you do the execute, they typically will do something. And so what is that something that goes on? Now let's see, so bake bread, bake cake, bake donut, or baking commands, how do we use this? So then we go back to our bake item, and we're still going to use the factory pattern, only instead of returning the objects, we're going to look at the commands. And then if the command isn't null, we'll call execute. This becomes helpful because typically when you're executing a command, that command gets handled. There's a handler, and in that handler, or maybe you just have it within the execute itself, there's logic there for that particular thing. So if it's the bake bread execute, these are the steps for baking bread. If it's the bake cake command, then when you call execute, it'll do the things for baking cake. You've got more separation. And so you can easily add more baking commands, allows you to keep the code more modular and easier to test because everything is separated out like that. Now, I know some people are worried about, okay, now we're breaking into all these different files. Is that going to overly complicate things? It can, it depends on your code base. But the thing is, again, understanding your code base, understanding these patterns and when they actually make sense for your application. All right, questions so far? Got a few more anti-patterns to show, plus some upcoming news as well. All right. Looks like we're okay so far. Those on YouTube, I am also watching the YouTube chat in addition to our Zoom chat locally. So rest assured, I am watching for questions if they come up. All right, so the next anti-pattern that I want to show is long parameter list. How many of you have seen functions like this where you're just like, all right, there's the function name. Keep scrolling and scrolling and scrolling, and then, okay, there's the end of the parameter list. Now what actually happens in the method? And sometimes you forget what the method's doing because the name was up a few scrolls. I've seen it. It gets painful. So you end up seeing this list here. This is actually short. I have dealt with pages upon pages of parameters, sometimes for a function, and I'm just like, oh, why did they do this? So there's going to be a couple things we'll talk about here. The first is we're going to talk about this: is chocolate, is vanilla, is strawberry. Or these are also known as flags because they're bools. And if there's a case where if it's chocolate, do this, if it's vanilla, do this, if it's strawberry, do this other thing. What happens when if you're like, okay, what if it's white cake? What if it's red velvet? What if it's carrot cake? What if it's banana cake or Dayton walnut cake? So now you have all these bools. Do you really want all those bools? That gets to be lengthy and harder to manage. It might make sense, depending on your use case, to combine all those and break it back down into something like an enum. And, or you can do it as a bit mask as well. So enum or bit mask. So you can do this where you can say, okay, if our cake flavor is chocolate or vanilla or strawberry, rather than having flags for each one of those, just toggle off of your enum itself. That could be an approach. And then notice what happens to our list here. Got the cake flavor now, thanks to our enum here, that is chocolate, is vanilla, and is strawberry. Can be done based on a check on the cake flavor. Then the layers, the frosting type, and the frosting quantity are still there. It's a shorter list, which is okay. However, we could probably do a little bit better. So the next thing we could do is we could just preserve the whole parameter object that's coming through. And that's when you see, and especially with .NET, one of the parameters that you commonly see is something options. This is why you have those options, is because sometimes those options are required and lengthy. Sometimes they're optional. It's a mix. So what we end up doing is we take our parameter list and we put it into a class so it's an options object. And then our bake cake, we just pass in the options that way. So that just moves a parameter list into its own class. And you're seeing the code, just to be clear too, you're also seeing the code like public class, and then you've got like the void here. Understand that there could be separation of files, but this is just to show you how the code comes together. Separation of files makes it also easier as long as you store them logically, as long as you arrange them logically. All right, primitive obsession. This is another anti-pattern, and this is where we get into things like you see strings and ints and doubles and decimals or floats. You just see the primitive types. You don't see object types. You don't see any details. This is going to get tricky, so bear with me on this. We're going to talk about cakes and sizes. One of the other code smells that I see, and especially with C# and with Java, is when I have an object or a class, and that class has a lot of string properties. When you see a lot of string properties, keep an eye out because there's going to be some kind of anti-pattern probably there. Now, if the field actually makes sense as a string, that's one thing. So like first name or last name or given name or whatever, like an address field perhaps, okay, a city name, that makes sense. But a size as a string, as a data person, I see that string size and my heart sinks because that means that the user could put in anything for size. They could put small, medium, large. They could put like 8" with the double quotes, 8 with IN dot. Inconsistencies galore. So you can see already this is an anti-pattern in many forms. One is relying on primitives and two is relying on strings. Now the excuse I hear with strings is, oh, JSON deserialization and deserializing into an object can be complicated. It can be, I get you. But you have to get away from the strings eventually and get it into a type so that you can treat it appropriately. But with this primitive obsession, the goal is to get away from the primitive types and introduce objects. So here we have the replace primitive with object. And that whole string bit, it's not enough. As my one math teacher used to say, you have to label your answers. Is it apples, oranges, peaches, bananas? Wow. So when it comes to size, are you talking about things like inches and centimeters? Are you talking about some kind of industry standard unit that might not necessarily be understood by somebody who looks at the code later? You want to be consistent and you want to be clear in your code. So maybe you have a unit, and then your cake size is actually a unit in value. And of course, override toString to make it easier to read. But then see, so refactoring our size from a string to an object, now we can get a little bit more detailed with the value and be more clear as to what we're expecting. Which is okay so far. But sometimes going the enum route can also seem a little challenging. So you might be like, all right, well, I'm just going to go ahead and say, let's go to cake size. And I'm just going to do a nice simple cake size of small, medium, and large. Small, medium, and large can be relative terms. And what's small and medium and large for US bakeries may be different for French bakeries versus UK bakeries versus Thailand bakeries versus everywhere else. And I mention those places because I know we have viewers from all those locations. So small, medium, and large, while I get what you're going for here, this could also be seen as an anti-pattern because it may be just so relative you don't understand what's going on. To get around that, convert your type code to a subclass. So we go from our enum, we have an abstract class, and then we work with, okay, now we have the small class, medium class, and large class cake sizes. And we can say their diameters are 8 inches, 10 inches, and 12 inches. So you can do that this way as well. Now, managing this, and enum might make better sense. It's going to depend on your situation. It's going to depend on what makes sense for the problem you're trying to solve. So whether you blow it out as far as getting into the details like this, or maybe that enum is enough and it makes sense. So that goes back to the question of, is this always an anti-pattern? And the answer is none of these anti-patterns are always anti-patterns. Sometimes they are the right decision. Now let's talk about loops. So when I mentioned that there's going to be one where people are going to be like, what? How are loops an anti-pattern? This goes back to the lack of knowledge or lack of experience. So loops can be an anti-pattern. And we're going to take a look at this particular loop. So let's say that we're looking at our baked goods and we want to sum the total of all the baked goods except cakes. Cakes we're going to treat differently, so let's keep them out of this calculation. Okay, so then we're going to go ahead and create a function to calculate the total and loop through our collection of baked goods. And if it's a cake, continue on. We don't care. Otherwise, let's go ahead and add the price. Then in the end, return the total. Now you might be going, hey, that makes sense. This is a loop going through a collection, doing some stuff and returning a calculation. Yes, however, it's seen as an anti-pattern because you can write it so it's in a way that is more readable and may also be more maintainable, especially with your team's experience. So keep in mind what this for each loop looks like, because the next slide is going to look a lot shorter. Any guesses before I go on to the next slide as to how we replace the loop? Yeah, Peter's asking link, sure enough. Link's where it's at. So in this case, if you're not familiar with link, then we'll make sure to include some link resources in the email, in the thank you email. But basically, link allows you to loop through these collections. So there's our where clause rather than the if continues statement. And then here's our sum rather than having that plus equals and that whole for each. The iteration is handled for you with link. It helps when dealing with loops to either have a solid understanding of link in terms of just the .NET ecosphere. Also helps to understand functional programming. And I know some people are like, but what does functional programming have to do with loops? There are a lot of concepts over there where we talk about things like map and apply. So you have a collection and you apply another anonymous function, for example, to that collection. This is something that's normal in functional programming. This is something that we can do. And if we treat our data as just data points and don't get so wrapped up over objects and object-oriented, know that you can take functional approaches to calculations, and it might actually be the more maintainable, easier to read way. Now let's talk about data classes. And when I first was talking with some people about data classes, they're like, wait, that's an anti-pattern? I'm like, hold up, hear me out on this. It's the implementation of it all that you want to make sure that you get it in a better state. So I've seen many data classes where it's, okay, we've got all of our different fields, we have all of our different properties with their getters and setters. To which my first question is, do you have to have the setters? And everybody's like, well, no, we only need to set it at first. Okay, so is the class the right way to go? Well, not necessarily. That's right. So let's take a look and see what are the ways we can handle the data classes. Because for me, yeah, Jean-Paul already sees where we're going with this. Records is one of the approaches I will take. That's this slide here. And so if you need it immutable, records are beautiful for that. This is all you have is your public, your record. your record name, and then your parameters. Records are simple for that. When I first saw records, I was like, Python data classes. Now in C#. This makes much more sense. It was good to see because of the simplicity of it all. If it's fine and it doesn't have any behaviors, this is the key thing is if you have a data class that doesn't have any behaviors, then the record makes sense. Again, looking at our class here, there aren't any behaviors. These are just all field properties. So fine, a record makes sense. The other question though is, what if it's actually a data class that has behaviors? Well, if that behavior makes sense, then if it's supposed to be immutable, remove the setters and then add your constructor to set those properties at creation time and creation and initialization. So you'll notice no sets in here. This is still a class, but this then anticipates that there's going to be some kind of behavior as part of the class. That's the part where when you're trying to figure out between class and record, if there are behaviors, record is not what you want. That's when you need a class. But if it is a collection of just fields or a collection of just properties, then a record may be what you need for data. Another approach that we can take is that maybe you just need the record and then pass that into a method. And that's fine as well. I'm just so excited when I saw records because it solved that problem. All right, the anti-pattern of the middleman. Now, this particular example, I can't stress enough, is just for code. Do not think of, oh, now we can have stores where we get rid of the manager. Hold up, that's not what I'm saying. For this example, we have a bakery manager that has a baker and it has a cashier. And it will tell the baker to do the baking and the cashier to do the selling. Is this bakery manager class in the code adding any additional value? Other than being an orchestrator or a micromanager because it has to know everybody and tell everybody to do something, it's really not going to be as helpful. Now, I have to be clear. When you see the term middleman, you might also see, oh, well, what about the mediator pattern? These patterns, they have their places, they have their time and place to be used, but they can be overkill, and they can be unnecessary. So with this anti-pattern of the middleman, it's when you have a middleman like this, you need to make sure that that middleman has value. If they don't have value, cut it out. That's just code that you really don't need to maintain. Break it out again, going back to our friends at the single responsibility principle, we have a bakery, we have a cashier. Actually, that could just be the baker that does the baking and the cashier that does the selling, but you separate that out and no manager. Now that said, the manager is the one who keeps things flowing on the outside. It may be necessary, so don't think this is the golden solution to everything. Just know that this is an option. All right, we've got, how are we doing on time? We have about 10 more minutes. Okay. So then we talk about the message chains. Think about it here. So when you make a cake or when you follow a recipe, for example of cake, let's say we have a chocolate cake and then we have a vanilla cake. So the chocolate cake, in this example, we're going to add a layer, add frosting, add sprinkles. So there's all these chains we have to do before we get to bake. Now, this is something you will commonly see with the builder pattern where it's chain, 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 and then build. So this is a pattern that you may actually consider, but there might be a different way to implement it. And that's why this is seen sometimes as an anti-pattern. So what can we do? Well, there's a refactor thing called hide delegate. And what does that look like? This is the only one that's side by side because it makes sense for me to show it. Because delegates can be one of those that people are like, how did that work again? So we've got this create cake process delegate. It's a function that takes in, it's a function of cake returning a cake. And so we have this create cake process and what you're going to pass in there. So the cake maker itself, that's here. This is our constructor. We're going to give it a process. And then we're going to return the value when we do create cake. This overall is what I like to call is the secret sauce. That's the overarching recipe. Now, when it comes to here, so now you're not locked down to all cakes have the same chain. Now I can say my chocolate cake, for example, has a layer. It has chocolate frosting and rainbow sprinkles, and then let's go ahead and bake it. Whereas vanilla, no sprinkles for them, and they have 2 layers. So notice that the chains differ up until bake. And then after the bake, it's going to return a cake. So the cake maker is still going to return a cake. It just has a new process in here. This is where you get into the delegate part. So you can still have the chains, but you don't have to say that all cakes follow that same chain, because chances are not all cakes are going to follow the same chain. All right, so we've seen a lot of different anti-patterns today. We've seen long functions. We've seen mysterious names. We've seen a few of the other ones as well. So we saw this one here. We saw the switch statement nightmare. We've seen where you have to refactor the code out into separate functions and separate classes. Even with loops, there's an anti-pattern with that where LINQ makes it more readable. So we've seen a bunch of anti-patterns. But the question is, are these always anti-patterns? And the answer is no. Sometimes they actually make sense and they're the right decision. Another question is, do I always have to do these refactorings from scratch? And the answer is no. Learn your IDE. On the Nibble Pros YouTube channel, there's going to be a few new videos coming up here where we talk about how do you use your IDE for things such as refactoring. And why would you consider this, and how to make your life a lot easier by learning your IDE. Now, I use Visual Studio Code. I know some of my teammates also use JetBrains Writer. I also use Visual Studio for my bigger C# projects. There are other tools out there as well. So stay tuned to the YouTube channel. We'll talk about how you can better use our tools. But know that you do not always have to do these from scratch. And especially when you have variable names in comments, make sure to check that include comments. Let your IDEs help with that. Now, another thing that you might wonder is, well, how can we be better at refactoring? There are a few books that I like to recommend. So the first one I actually have here on my desk, this one here, is Refactoring by Martin Fowler. This particular screenshot's the 2nd edition. The 1st edition is just as great to have on hand, but it gives you various suggestions. And actually, let's see if I can show you the back cover. I don't know if it's going to show nicely in the video, but there are a list of smells plus additional refactoring solutions. So this is probably one of my favorite refactoring books to have on hand. Another one that I have that I don't have on my slide is Refactoring with C# by my friend Matt Eland. So he wrote a book on how you can deal with that using .NET 8 and C# 12. Then there's Refactoring to Patterns by Josh Karyevsky. Again, how do you refactor to patterns that make sense? And I can't stress it enough, that whole golden hammer thing. See these refactoring options as tools. Don't think that one is going to solve all the problems. Those are situational. The last one I have on here is Code Complete. And this is the 2nd edition. This is another one that in general, from how do you write code that is easy to read, easy to maintain. And then, oh no, I have legacy code and how do I refactor it? It's another one that I highly recommend. And then if you're enjoying these webinars, we have 2 more here in 2024. So Clean Architecture with .NET 9 is also going to be another one where I start on Zoom and I stream over to YouTube. And that's going to be November 21st at 12 o'clock US Eastern Time. By that point, for those of you who are not in the US, we will have our clock shifted, so that should be accounted for, but pay attention to our YouTube channel if you want to see when it's going to launch in terms of time zone offsets. And then for December, I'm going to share the gift of dev containers, because dev containers has made my life easier having to maintain various projects in various different versions of Node, plus a Ruby project, plus a PHP project, plus some .NET projects. I don't want all that tooling to make a mess on my desktop. So Dev Containers has solved a lot of those problems. So I will share my love of Dev Containers with you all in December. And we'll also show how to include that in your CI/CD pipelines. Are there other questions about anti-patterns or refactoring or anything you saw in today's webinar? A couple last slides. So we are running a special deal for our Introduction to Clean Architecture course. So you do hear me mention clean architecture from time to time. We released the course in August. It's about spooky 20. Between now and October 31st, we have a 20% off code. Use spooky 20, and the courses are at academy.nimblepros.com, but I figure a bit.ly link might be easier to remember. So bit.ly/learn-clean-architecture. If you go there, use spooky 20, you'll get 20% off the clean architecture course today through October 31st for the first 100 uses. We have a couple courses coming up between now and the end of the year, so stay tuned on that as well. And then if you're interested in more help, if you need help implementing DDD or CI/CD, any of the topics we cover in the webinars, if you need help implementing it in your workplace, if you need help educating your devs on any of these topics, please reach out to us. There are humans at the end of those contact emails, and we're the ones who end up meeting with you to talk and understand your project better. And then hopefully we can pair with you on your problems as well. Thank you all very much for attending. And for those who signed up for the thank you email, that will be going out later today when I have the YouTube link all squared away. But thank you.